Well, hello everybody, welcome back to Bison Workshop. I'm Bob. I wanted to do an update on the control box for my mill. I've got everything done except for the tachometer for the head motor or the spindle motor. So been kind of under the weather. I got a virus or something, man. And right now I can't hardly hear because my ears are just liquided up, I guess. Sneezing, coughing, gagging. But I'm gonna put you down here and show you what I got. Now forgive my mess. My shop is a mess because I'm in on my gun bench and it has become a clutter-all. And one day I'll get her straightened out. But for now, let's look at what we got here. First, we got this one here is going to be in the place of the spindle motor. This one is going to mimic the X travel for the bed. And this one is going to mimic the Z-axis motor, which is 24 volts. So we got 24 volt, 12 volt, and 90 volt motor DC. So now let's show you what's in the box. What's in the box? First of all, we got a fuse, and it is unplugged. We got a fuse length that's going between the bridge rectifier and the control box. So I've mounted the control box here, and I had to do a bunch of modifications to it. You see these screw heads right here, or bolts. Those are to screw the fan to this plate, which I don't know why they didn't make holes for that fan and put screws in it. But they have it dangling in there, and it just moves around, and I don't like my stuff like that. So if you had this and shook it around, that fan would be moving back and forth. So I fixed that, and then I made a new mount to screw in the back side of it and threaded the heat sink so I could put a bushing between the two. And this is an added way of mounting the board and everything and the heat sink, because the heat sink and the board are connected together. So there was nothing over here to hold it. The heat sink didn't even go far enough to grab the stud or the bolt hole that's there originally. They could have just took and put a screw down in if they'd have placed that in the right place. But it's solid now, and I've got a AC choke. And yes, it's not a choke. I can't remember the name of it, but it's like a porcelain ring with the wires wrapped around it, and I could only go 6 because that was the biggest ring I could find. So we got our AC coming in, AC going out, and it's going out to this motor or to this controller. Then it comes out of the controller and over to the bridge rectifier, or the bridge rectifier with the white, and then the black goes up to the fuse, comes out, and then goes to the other side of the bridge rectifier right here. And I just put heat shrink around it because I've got 1032 screws that mounts these eyes to the post. All I did was took a 1032 tapped those holes out that's in the original, the way it came originally. I'll show you a picture of what it looked like. Well, all those holes you see, I threaded, and they were the right size for threading size for 1032. So I wallered them out with a drill bit anyway, just to make sure they was perfect, but they were a little tight without drilling them, so I drilled them out a little bit to thread them. So then we're going out of the bridge rectifier we run the hot wire to the, or the hot side to the choke, and then out of the choke to the switch. So it goes up along here and around through here and over there. So basically this row right here is for the power feed on the x-axis. This, and this is for the spindle head. And then this is for the z-axis up and down. So we've got 2 or 3 double pole, double throw switches. The only difference between this one and these two is these are not momentary switches. These are switches that when you switch it, it's there. You can let your finger off of it and it'll stay where it's at. Simply because we don't want them to stay, or we want them to stay on, because if you're power feeding, you don't want to sit there and hold that switch the whole time. So this one here is the momentary switch, so that when you're raising and lowering the head, you let off of it, it stops. So I also want to add limit switches to that, and that'll come later. We'll see how that goes. So back to this part. What I did here was took a 3D printed part that I made and made me a power rail. The power rail has 24 volt, 12 volt, 5 volt, 3.3 volt. Turns out we're not going to need the 3.3 volt or the 5 volt. The only two that we're going to be using are these. And because I had an open slot on that, I used that instead of this. So if I ever wanted to add 24 volt something to this, I've got the lug there for it. And then I've got my ground rail right here so that I can put wires to it. And I'm going to be replacing that with a bigger one, a longer one. So that's our 24 volt power supply. That's running the Z-axis motor. Then we got our 12 volt that we're running the X-axis motor for the power feed. And then this unit here is for these two, and this are for running the spindle. So now we get to test these and see how they're working. And you know I've already done it, but I just wanted to show you guys that it does work. So let me get you all centered there. I put tape around those so you guys can see them running. So let's throw some power to it. And let's turn it on. I want to see if that's a little quieter when I got the lid shut. So now we can go ahead and shut this lid. And you got to be careful when you're running these wires, so that they go down in there and rest easy. Now I'm going to do some pinning. I'm going to pin that to that wall back there, and that way I can bend that before it comes to this. But for now, we'll just close it like this, make sure nothing hits. It's a little quieter, but not much. Alright, so now this here is your X-axis for the power feed. That would be the 12 volt motor. So watch that tape. That's one way or the other. Might have to switch them depending on which is right. Alright, and then that thing's got some torque. and that's backwards. Alright, so now everything here is working. I can slow it down to a crawl. But for some reason, this is reading 93%, and when I'm at full speed, it's reading 0. If somebody knows what I can switch, I think I switched the two outer ones, but I'm not sure. I never switched them, so I don't know why they're wrong. It wasn't like that before. It was 100% when it was right there. Now it's reading 0, but if I go all the way to 0 where it's off, you can clearly see it's not working, but it's showing 100. I don't get that. So anyway, so there's that. Then we've got the Z-axis, which would be this motor. And like I said, I may have to switch. So if I let that off, it goes to off. If I let it off, it goes to off. Alright, so then we've got our spindle motor, which is this bad boy right here. Nice clean too, sounds real good. So I'm hoping that we've got some pretty clean electricity going through that. Alright, so now turn it off, and now we're going to go the opposite direction, which is clockwise. That's clockwise, counterclockwise. Alright, so I got to replace the potentiometer because I need to put a 150k ohm resistor or potentiometer in there, and then I have to add the wires for the tachometer. So I don't know if you guys are in frame or not, but I imagine you are. So I just got to hook this up to the power. I don't know what I've done with my plug that goes to it. And then I got to hook this up, and I don't know how I'm going to do this. I was hoping to use the actual one that came with the mill originally, that goes on top of the spindle, that's got all the holes in it and the sensor's all there. The problem I'm having is these wires, there's 3 wires on this one and there's 3 wires on that one. This one's got brown, blue, and black. The one on the Grizzly has red, white, and black. I'm thinking black and black would be the same, but which one would I use for the red? Would it be the blue? And would the brown be for white? I don't know why people can't stick to a standard, man. It's like everybody's got to change something and keep everybody confused. So it's either I'm going to have to try to figure out how to wire these things, because it does not give you any indication as to what they are. It don't tell you if it's got to be input or voltage, or if it's a signal or what. I know that the magnet's supposed to pass by this and create an electrical quick pass by electric that will read the magnetic or the magnetism every time it goes past it. Now, if anybody knows what the pinouts would be for this, let me know. Like I said, this one's got blue, brown, and black, and the original one has red, white, and black. That's the one that came in the Grizzly mill to begin with. So, I think I've got this set up now to where I can use this for a power supply for my shop, because I plan to add lugs to this thing. I just want to try to get it mounted and working with this stuff in it, and then just go with it as I need it. Because right now I've been using a 12 volt converter that plugs into the wall. That's got an old one. It's got a lighter hole in it for a charger. Not a cigarette lighter, but it looks like a cigarette lighter hole. And it's got 2 lugs on the front of it for 12 volt, so that's what I've been using. So now I can use this. I've got lugs that I can put on here in this area right here next to these this breaker, and I can put them lugs right there and have 12 volt and 24 volt hookup. So I can put both of them there. I'm not sure I like the ones that I bought. The ones I got, I think they're for running through plastic. So I may have to 3D print some plastic plates and cut out this area and then make the plate where it mounts, and because the studs don't have no bushings around them. Or I can just put bushings in them and drill the holes bigger. Duh. Those are going to be some thin ass bushings. But they didn't come with any bushings. So if you drilled the hole and put them through there, the studs would actually hit the frickin' metal. So I've been working on this thing off and on for the last couple of days, and I think I'm finally starting to get there. We did, however, I'm excited to say, for the first time in my life, I finally get a real DRO. I sold my Arcticat, and I decided that a little bit of that was going to go into my tooling. So I bought a DRO for this mill. So now, we didn't do all this job for nothing, making these DROs work on an external 3.3 volt system. They can still be used. It's just, I just decided it ain't going to be used for this now, because I've got a real DRO coming. And here's a picture of that right now. The bad part about that is I can't use my coders or my readers. They're both magnetic readers or scales, but I can't find a plug or an adapter that will adapt micro USB to DB9 plug. I can find it micro USB to DB9, but the way it works, it's a male micro USB, which means you'd have to have a female to plug into it. Well, my plugs are not female, they're male, so I need a female to DB9. I can't find it. So if I could have done that, I wouldn't have had to worry about anything. I could have paid $79 for a DRO and had my scales already. But no, that's the only freaking adapter that they didn't think of. That's my luck. Also, I'm getting ready to build myself another air compressor. The air compressor that I've been using does not belong to me. It belongs to my landlord, and from day one I've hated the thought of using his air compressor, because I know that if anything breaks on it, I'm the one responsible for fixing it. Well, it's been mistreated before I got it. When I first got it, was using it, the oil in it was almost like slimy black sludge that couldn't even drain. I had to actually put air on it to blow it out there, and I bet I didn't get it all. So I put new oil in it. Well, because of the way it was treated before I got it, I mean, some people think that the air compressor, as long as you hear it running, we don't care. Oh, it's still running okay. 2 years later, oh, it's still running okay. What they don't realize is they're destroying that thing by not doing maintenance on it. You got to change your oil in them pumps. You got to drain the water out of the tanks. Otherwise, you're going to have a rusty tank and a clogged up frickin' crankcase. So I decided that not only do I want to get myself my own air compressor, if something ever happened, I have to move, I wouldn't have an air compressor, because the one I got ain't going to be sufficient for anything. So I just went ahead and decided to get on Marketplace and looked for another air compressor. I found one for $450, well, $350, but I offered him $100 to bring it to me, because it was going to cost me as much in gas to go get it, or more, for me to go get it than it was for me to pay somebody to bring it to me for $100. Who knows, maybe I meet somebody that wants me to work on some stuff for them or whatever. One door will open another. So I'm going to take that air compressor, which is a 60-gallon with a 5 horsepower motor, and it's just got the single cylinder compressor. Well, I ordered this. This is going to go on that air compressor. So that is a 175 psi, 5.5 horsepower. I think 5 horsepower will run it just fine. So hopefully I'll have a decent air compressor that doesn't make a lot of loud noises, that clinks and clanks, and every time you turn around something happening to it. I've done replaced the switch on it twice. I've done an oil change on it, and it just doesn't seem to want to hold up, because it's just been mistreated. So we're going to probably do a video on the air compressor, on the modifications. I'm sure there's going to be modifications, and then the DRO, we'll do a video on that. And I feel like I need to sneeze, and I do. Ah, damn it. And don't nobody comment, God bless you, because I don't believe that. Anyway, so we ended up with a little bit more room on the front of this thing, since we're not going to be putting the DROs on it. So then we can shut it. And what did I do with my, got my lockdown thumb screws that apparently I've lost one. They should both be right there. They are. Probably need to shorten those. But I'm tickled. So we're not going to be far from mounting this into the area. Now what I decided to do, I think I've got it down to where I'm going to put this on the left side of my mill and the DRO on the right side. I don't know how inconvenient that's going to be. If it does turn out to be inconvenient, then I'll mount them both on the same side right beside each other, which may be a better option. We'll see. I plan to make one of these for the lathe. Of course, the lathe is not going to be this involved. The lathe is pretty simple. Forward, backward, speed, up and down, and a tachometer. So, still gonna have to get a switch for it. One of these magnetic switches, now that I know how it works. So, I didn't realize that these buttons were magnetic. So in other words, when you turn it on and you lose your power, the switch will go off. And if you try to turn it back on, it won't work. You get nothing. So it just feels like you're hitting an empty button. But the very moment that you turn it off and turn it back on, then it will work. So watch. We got it on. Now I'm going to unplug it. So now let's plug it back up. Nothing. You got to re-hit the button. So the magnet in there is energized until you lose the power. Once you lose the power, there's no more magnetic forces going on, and it lets off, turning the switch off. So it's a safety switch. It takes a while for it to come down. So anyway, that's my box for the mill, the Grizzly mill. I got to change the potentiometer and do a few little things to it, but I can't do nothing until I get parts. So now I'm just waiting on parts. Potentiometer is coming from China, and I'll probably change this knob here to one like this one so they match, because the monitors match, or the displays match for the speed of the x-axis, and the one for the tachometer for the spindle speed. So anyway, probably made this a little bit too long. I hope you guys learned something about how to hook these up, and that yours doesn't have to be like that, but that's just my idea of how to set one of these up. And who knows, maybe next year or years from now, somebody will come up with a better way to run a treadmill motor, and have something a little more robust. But this seems to be the best that we have available to us today without having to go buy a VFD. So getting into VFD, I hope your wallet's not a screamer, because it's going to get screwed. And if it's a screamer, the whole world's going to hear about it. Anyway, y'all have a good one. Later.